One specific type of discontinuous function is called a piecewise function. A piecewise function is a function that's built from pieces of different functions over different intervals. So here we have an example of a piecewise function, the graph as well as the actual equation. So if we look at the graph and the equation, we can kind of just figure out which piece goes with what part of the equation. So let's look at this first piece. So this piece that we have here on the left, I'm going to kind of outline it in blue. I'm just going to call that 1 for right now. That's going to correspond to the top equation. So when you're writing these piecewise functions, you go from on the graph left to right, and in the equation top to bottom. So the leftmost graph on the graph is going to go with the topmost function in your equation. So here, let's look at the next piece. So the next piece is this horizontal line. So I'm just going to call that piece number 2. And that's going to be corresponding to the equation in the middle. And then the last piece is this piece here. And that's going to correspond to, we'll call that number 3. That's going to correspond to the last equation. So if we kind of break this down a little bit, the first thing that you have here in your piecewise function, this is going to be the equations of the lines. And you're writing each equation that you have for each graph. And then this second piece, this is your domain. So that's going to tell you where the graph is starting and where it's stopping. So if we look at the blue one, so number 1, we can see that the blue x values, we're going from -3 to -1. So since we're going from -3 to -1, that's the domain for this blue piece. We can see that that is the inequality that we have listed that goes with the first graph. Okay, the second equation here is 2, and we can see that that makes sense, right? That's a horizontal line at 2. And the green, okay, we can see that the domain for it is from -1 to 3. And notice that here we have an open circle. So I'm just going to emphasize it. And when we look at the inequality, okay, we'll notice that at -1, it does not include it, and at 3, it doesn't include it. Okay, so 3 not including it makes sense because it's an open circle. The piece here that's a little bit confusing is that, I'm going to actually erase this so you can see, the actual graph is connected here. So when you have a piecewise function that is attached, like the two pieces are attached to each other, that means that one of the equations is going to include that point and the other one is not. So usually it doesn't matter. So if you're writing your own, we'll see later how you can kind of do it either way. So in the first equation, the -1 we included with the first equation, and we didn't include it with the second equation. Now, if you had this not here, if you didn't include it here, and you did include it in the other piece, so if this was, let's just say, not there, and then you put the line here, okay, that would also be correct. So whenever they overlap each other, we just have to be aware that one of them will include it and the other one will not include it. So in this case, they included it with the first one, and that's totally fine. And then this last piece, this purple piece, number 3, you can see that there are closed circles on both ends, and you can see that the x values are going from 3 to 4, and that's going to be where our interval is. So you just want to make sure that you're paying attention to the open circles and the closed circles. So when you have an open circle on the actual graph, when you have the inequality part of the piecewise function, an open circle, I'm just going to write it here, open circle is going to correspond with, put a little line like this, either just the greater than or the less than sign without the line underneath to include it, since it won't include it. When you have a closed circle, that's when you're going to have greater than or equal to or less than or equal to. So just remember that open doesn't include and closed does include. So now we're going to actually graph a piecewise function. So when we're graphing a piecewise function, the easiest thing to do is to think about it in each piece. So what I'm going to do here is I'm going to call this equation 1. So x plus 1, I'm going to call equation 1. The domain that they give you, you want to use your endpoints and plug them in. Okay, so you could graph x plus 1 as a normal linear function and then cut off the pieces that aren't part of the domain, but that's actually going to be a little bit more work. So down here, what I'm going to do is I'm going to write out the steps. When you're doing this, you don't necessarily need to write out every step, but I'm doing this to show you kind of how to do this. So the endpoints are -4 and 1. So I'm going to check the endpoint when x is -4. All right, so I'm taking the left endpoint first. What I'm going to do is plug that in for x in this equation. So I'm going to say that y is equal to -4 plus 1, which is equal to -3. So that means the point -4, -3 is going to be on my graph. So I'm going to go to -4, -3, and I'm going to put a closed circle because my inequality symbol includes it. Okay, I'm going to do the same thing for my other endpoint. So I'm going to take the value when x is equal to 1. So again, I'm plugging it right here into x plus 1. So the x value is 1, so 1 plus 1 is going to give me 2. So what I'm going to do here is now write the point. My x value is 1, my y value is 2. So at 1, 2, I look to see the inequality symbol. It includes it, so I'll have a closed circle. So at 1, 2, I have a closed circle. Whenever you're graphing these, you want to make sure you have 2 points because 2 points creates a line. So now I'm going to connect these two, and that's the first part of my graph. And now I'm going to do the same thing with this second equation. So I'm just going to call this equation 2. And here I have endpoints of 1 and 3. So I'm going to plug 1 in. So I'm going to say, okay, when x is 1, y is going to equal -x, so -1. So that means that that's the point 1, -1. Now notice here that this 1 does not include it because it does not have the line underneath the inequality symbol. So at 1, -1, I'm going to have an open circle on my graph. And then I'm going to plug in 3 as my other endpoint. So x equals 3. So y is equal to, I'm going to plug x into here. So y equals -3. So this would be 3, -3. And we can see that it includes 3. So at 3, -3, we have a closed circle. And again, I'm going to connect the two blue, to make this graph. Pretend that that was good. It's not, but we'll just make this a very thick line. So here's that line. Okay, so there's my piecewise function. Okay, so we're going to look at one more. So here, again, we have pieces. So I'm going to break it into each piece. So I'm going to take the first one, which is our top equation, and I'm going to plug in endpoints. Now notice here that there's only one endpoint. So if I plug in when x is -3, right, f of x, which is y, is going to equal 2 times -3 plus 4. So this is going to equal -2. So this is going to be the point -3, -2. It does not include it since it doesn't have a line underneath. So I'm going to go to -3, -2, and I'm going to have an open circle. Okay, now from here, because this extends for every x value less than this, we want to draw the line for that piece. But we can do this one of two ways. You can either count the slope, right? So here, the slope would be 2 since it's in front of the x. So from this point, I can count a slope of 2 going to the left, so going down 2 over 1. Or just pick a value of x that's less than -3. So I'm going to just do that so we make sure that we have the correct line being drawn here. So I'm going to pick x as -4. So again, I'm just going to plug that right into the same equation. I'm going to do 2 times -4 plus 4. And when I do this, I end up getting -4. So that means I'm using the point -4, -4. And I'm going to just make that a dot because it's including that anyway. I'm going to connect these and I'm going to draw the arrow. Okay, so remember, 2 points creates a line. So if you only have 1 point, you need to have one more point somewhere on that line in order to connect it. So then we look at equation 2. Now equation 2 is just a number, it's just 1. So that's just the horizontal line that goes through 1. So we don't really need to plug in points. I can't plug in -3 and I can't plug in 4 because there are no x's. So I'm just going to go right to my graph and I'm going to go to where x is -3 and the y value has to be 1 since that's what's here. So every single y value for this function will be 1. So negative 3, 1 is a point, and it includes it. So here's negative 3, 1, and I'm going to have a closed circle. And then I'm going to plug 4 in, but there's no x to plug it in. So when x is 4, y is 1. And again, look at the inequality symbol. It does not have a line underneath, so we're going to have an open circle. So at 4, 1, we're going to have an open circle. Okay, we have 2 points, so we can connect it by drawing that line between them. And then our last function, equation number 3 over here, okay, again, has that one endpoint. So I'm going to plug that in. So I'm going to use equation 3 over here. So x, we're going to say, is 4. So I'm going to plug that in and say f of x is equal to negative x, so negative 4 plus 2, which is equal to negative 2. So the point for negative 2 I'm going to use, and it includes it. So here's 4, negative 2, close circle. And again, we need 2 points to create that line. So I'm just going to pick another x value that's greater than 4. So I'm going to pick x equals 5. And I'm going to plug it in and get negative x, so negative 5 plus 2, which is going to give me negative 3. So the point that I have here is 5, negative 3. And again, you could count the slope. It's a negative x. So from this point, I could go down 1 and to the right 1. Or you can just do what I did and pick an extra point that way. And then I'm going to draw it and make my arrow.